We start our first topic today with Internet of Things, unifying global data with the Wolfram language. So some of you might have a few curious in the mind why today with the event of Wolfram Research Technologies 2016 we start off with such a topic. And according to recent research, I'd like you to bring to your attention, and this is one of the research done by our, yes? Oh, that's all right. I'll try to show it to the next graph is along. Thanks for reminding. And this is a research done by our one of the major private R&D corporations, MIMOs in Malaysia, who drafted out the blueprint or roadmap for Internet of Things in Malaysia. According to our research that you see on left-hand side, there's all figures happening today. That's based on Malaysia's. The Internet penetrations, the users of Internet, and the mobile devices. So according to a projection, next 10 years to come, Malaysia's go at least 2 times or 3 times in terms of Internet users, or in terms of mobile devices, meaning that everyone of Earth will averagely own about 2.8 unique or different mobile devices, according to our research. Also, each of us here, quite likely, we not just an internet account in company, but at home, also a mobile phone. That's what it means about 195% growth. So if you look at the USD dollar here, meaning it's in 10 years to come, this is in billion USD for Malaysia, not global value. There's a total value market, MIMO's projected about 16 billions in 10 years to come. That's a huge amount of investment we are talking about. If you look at the chart here, compared to traditional ICT expenses, meaning that in traditional investment in terms of like server, laptops, infrastructures, things like that, on the bottoms here, orange color, and at the same time, the investment on Internet of Things, on mobile devices, storage, and application will grow almost twice the figures 10 years to come in Malaysia per se. So that's why today we will start off with Internet of Things and how Wolfram Mathematica technology play a role and how we play a role in this trend in the next 10 years to come. Now, in a simple Internet of Things component, there are 4 parts. So first part here, of course, is all the mobile devices, web services, and the connected devices could be your mobile phones, even your smart home appliances like refrigerators, even rice cookers, thermometers, a light bulb. All those these days become internet connected. And of course, in our internet connected device must connect somewhere. You have to connect to applications, storage, data storage, or connect to some back-end server, and before it becomes some analytical data which is useful to feedback to consumer, to the users, what's happening out there. So I try to illustrate from the point of view of Wolfram research how we can play a role with the technology we have ready on hand with Wolfram technologies. So apart from these 3 components, of course, the 4th component we didn't see here in the backbones is networking. Of course, I think Malaysia is catching up. Like many other nations, we have more bandwidth, we have more the high-speed internet connection on the way. I think in the past, and whenever event starts, people ask, what's the Wi-Fi password? But this day, last 1 year, I seldom hear people say that anymore because most of us, almost all of us, will have all mobile data connected to you. Yeah, that's a trend. I believe that in terms of speed and coverage, this is something will be tremendous in the next few years to come. So I will not address on that part. So let's look at Wolfram data drop. When talking about storage, talking about calculation, what does Wolfram technology play a part here? Today I illustrate 1 or 2 quick examples. How could we do about that? First thing I think is a connected device in Wolfram language. If we go to this website, Wolfram launched this website just about 2-3 years ago, and it's quite ambitious. Now it have about 4,000 different devices registered with this website called devices.wolfram.com. What the intention of this website is, Wolfram Research intends for all the manufacturers or consumers registers the attributes of the mobile devices to this website so that all the users, hopefully, the important users of those devices can easily curate data, curate attributes. At this moment, they only can curate or access the attributes or the connected devices that register in the website. For instance, I want to know about this scanner. I want to know probably the scan rate. I want to know what kind of barcode it can perform. And Wolfram, through this connectors project, can easily curate and compare various scanners registered in this website. Of course, end of the day, the intention is we want to develop a framework that all the connected devices, we're not able to curate their manufacturer information, but we want to curate all the users' data who come into those devices. Same thing, Malaysia government is working very eagerly, aggressively on this. On the roadmap, they come out with memos in next 5 or 10 years to come. Malaysia spend huge money right now together with government, try to come up with a local framework so that all the Internet of Things connected device in Malaysia can work on this platform. At the same time, Wolfram already working on that since about 3 years ago. So I show you what is ready here. You could have the choice in future to work on a framework, what is developed by Malaysian government, or right now you already have the ability to test on a concept. What if I use a framework coming from Wolfram Research? Now, immediately if I run a coding here, those actually seen Mathematica before and you know what I'm working on and what I'm doing, but it's first time you see Wolfram Research Mathematica, this is okay. Those syntax, it might looks like alien language to you, it's fine, not to worry, because these days a lot of programming language is so much easier to master compared to 5 to 10 years ago. A lot of visa built in. You just tell them what you want to do, and it will bring you the subsequent stats 50% of the time, almost automatically. So the coding you see here seems like alien language, but actually it's not that difficult to master. So I will not explain too much about syntax I type. I just illustrate to you actually what it's capable of achieving. For instance, we type 5 devices. What it does here is immediately Mathematica find out what are those connected devices in my laptop it can recognize. So include those in a network. Hopefully this is something coming up very quickly. So now this function is available. Now, if we know that we could easily connect mobile devices or Internet of Things, important thing is Wolfram gives us framework or storage, cloud storage available for us to capture the consumer data or user data in a very easy manner. We call Wolfram data drop. How do we accumulate data in a cloud? Very simple. For instance here, this is one syntax that it can almost automatically actually created by this syntax called create data bin. But today I will not illustrate it because I already done so. Yeah. So if I want to quickly show you how easily I can connect to a cloud storage, I just do another thing. I say I want to create a database called my GPS positions. Let's say, okay, my GPS positions. And I want to create a particular field called location. As long as my laptop is connected to the internet, the moment I run it, this will create one storage, my personal storage in Wolfram drop. Yeah, so it's done. So if I go to my Wolfram data drop website and log in accordingly, this particular database already created for me. For instance, I have about 4 databases created very easily on the cloud, and I just created 5th one. Let me sign in. And for information, for those who want to test out this Wolfram cloud storage is free of charge. You can create up to 5 databases, as many columns as you want. So the latest database I created is called my GPS position. It's already created. I can encrypt it myself, meaning that only I myself can access or can share it in public. So I will not illustrate too much here at the moment, but to let you know every database in a Wolfram data drop can be a unique data bin ID. You can choose either you are only one allowed to access or the public can access it. So now, it seems we know data can be easily stored in Wolfram data drop or somewhere in the cloud in such a convenient manner. The next thing is we say, okay, what do we do with those data? Okay. Now, for instance, if you have a copy of Mathematica license, either it's a desktop version, a network versions, or the cloud versions, or online versions, you can do this immediately for the accessings. Let's say I connected that to my database called position. This is a GPS coordinate I accumulated in last few days. How do I do that? I'll show you later on. How do I capture my GPS position from my handphone into data drop, which is connected to my Mathematica on the desktop here. These are a couple of the locations I traveled in the last few days. If we have data available on a cloud, readily integrated into your Mathematica desktop or online or cloud version, you can do calculation right away. So all those data, not just numeric data, but image, all can be accumulated into the cloud storage called Wolfram data drop. So as soon as we have those thing data stored inside, the next thing you can do is you can perform a lot of scientific computation using Mathematica technologies at the fingertips. So now let's do some example here. For instance, I already import all my GPS location. I say, okay, please highlight it in the map. I run it right away. It shows these are the couple locations I have traveled in Malaysia. I went to Johor, I came to Malacca along highway. I just click on my mobile phone. It went to my Mathematica. The same thing you could do is you secretly install the same thing in your wife's mobile phone, husband's mobile phone. You can actually automatically, we have something called Tasker, which is free of charge. You auto lock that position. Of course, this kind of subscription is already out there. But I'm trying to tell you that as a layperson like you and I, we can do the simple thing, an easy thing, like what you probably have to pay for a subscription to track someone. And this is free. You can do it yourself with a good sense, good achievement. So now, of course, this is not something fantastic. If you say, Peter, I don't want to see graphic like this, could I show the geographic position in Google Map? Yes, by all means. Google API, all those, a lot of important these days web services, quite likely, I would say 80-90% are available or could be integrated to a certain degree in Mathematica. Yes, Google Map can be 100% integrated. Now, if I want to do further more advanced visualization, I say, okay, and not just want to see the particular location, I want to see my traveling path. How do I travel? I start from here, I travel all the way to UTM, we had an event there, I travel back to Malacca. Yeah? You can do a computation like that. More robust computation, you say, okay, Peter, this is not something impressive. And as I can do this in Google, map Google easily, yes, you could. But another thing is, for instance, inside Mathematica have a lot of geographical related function built in. We have tens or hundreds of them built in, important one. If I want to find out each location I stopped previously or I logged previously in my GPS, what will be elevation like? It should show up here. On this particular location I stopped, these are elevation. This is not something ordinary software can do. And secondly, of course, I can even track what will be the weather like. See here? This is, I just simply show up with the code here for all locations I stopped, previously stopped. What will be a real-time temperature right now? You show it on the map right away. Of course, we can show the weather data like temperature. We can also show other weather data as well, like raindrop, wind speed, and so on and so forth. Things that you can, it's just up to your imagination. We're not just able to show real-time data about the temperatures. Wolfram Mathematica, I once did some small project. We can backtrack with many weather stations in Malaysia up to 1970s. For instance, if you go to any weather station in Malaysia, say, can you give me the data of 5 years ago? I don't think I say, you wait lah, okay, fill out form, you come back maybe next month. But with Mathematica, you can take the entire historical data and temperature of certain city or certain GPS coordinate anywhere in Malaysia. I once done up to 1970s. So this is something that a powerful technologies that had never been made available before for research. Now, this is one part about GPS. The next thing is I show you quickly about this IFTTT. Yeah, just one example. Yeah, we have seen this Wolfram data drop. We say, okay, Peter, we had data. Okay, we had this. We can do this wonderful thing of tracking my husband and wife. Okay, how do I do a tracking? Where does the data come from? On the left-hand side here, all those mobile devices could be like, say, could be your household smart appliances, even a light bulb, even like web services like Twitter's. I think Farid might have some time to show you the Twitter's analysis of Trump and the presidency last week. I'm not sure whether he had time to show that. That is something very interesting and really blow your mind. So I show this IFTTT. This is one of the web services made available about 5 years ago. It's getting very viral in the market right now. It's free of charge thing. It helps to automate a lot of things. You can use this one to automate the website, automate your Twitter, automate your mobile phone, automate the switch on a TV at home when a kid is watching TV too much. You can use a mobile phone. Use this IFTTT, switch off. As long as you create the right recipe to do that. Yeah. So now I use this IFTTT as one example. How do I actually log my GPS positions? Okay, we are looking at screen in my mobile phone right now. Okay, if you can see a screen here, these are couples push button I created using IFTTTs. Those are free things. For instance, right now, if I can make it automatic, I could make it manual. For instance, I have something called do button. This is one. I click on that. Yeah, I do something manual. So as long as I turn on my mobile data plan or turn on my GPS location, just one click button. Now, whenever I click this button is provided by IFTTT, a free service, and palm my current GPS coordinate to my data drop. And since the data inside my data drop, I can easily pull out using my Mathematica to do a lot of analysis, like what I just did. So like for instance, the next example, I try to do an analysis not just on numeric result. I can also do analysis based on photo. I would like to ask my colleague Desmond, can you come here again? Can you quickly take a photo of some of us here and send by WhatsApp to me? I'd like to illustrate, not just able to analyze numeric data, but can easily manipulate and also analyze any images that come from any sources. Now, what Desmond is going to do is he's going to take a screenshot of some of you. Can you take something closer, not too far? Maybe it's just have 6 or 7 of you. I promise I'll delete that picture later. I just for illustration. Not to worry. If you don't want someone to find out, oh, you're actually sneaking away from a job. Okay, I'll promise I'll take away from Instagram later, just for a quick demo. Okay. So what Desmond done right now? He will send me a WhatsApp. Later on, I'll go and put that WhatsApp pictures into my Instagram. And this whole thing is automated because I create a data drop called photo. And in this data drop, it's already there, so I'm not going to run it. Now, if I want to see what's inside my photo, so important thing is I'll show you my mobile phone again to show what I have done. I'll switch on my WhatsApp. This is a photo that he just took. Then the next thing is I shared it to my Instagram. Done. It's up. So the moment it went up to my Instagram, in fact, now using IFTTT, auto pushed my Wolfram data drop. It's already there. So how do I do to prove this one? Now I go and run this coding to import all the data available inside my Instagram. I only have about 3 or 4 pictures. This is first pictures I loaded up my friends. Maybe it take a while to come out. Let me just run them one time. Oh, okay. Not to worry about syntax like this. For instance, I say I'll put quiet or map, all those things. If you are done through a training with us a couple of days, you can easily master this one. Oh, it's not yet. I haven't done my sharing. Okay, now it's done. Okay, now it's done. Okay. I'm not really Instagram user, so okay, still loading. Here we go. Yeah. So these are all the pictures available in Instagram, but I can perform some calculations. For instance, how about how many total pictures count in my Instagram? Instagram have very wonderful and powerful features they took away about 6 months ago because this privacy issue, and because for instance, Instagram you put a specific GPS coordinate, you can ask them to randomly give you 10 accounts, 20 pictures what they have taken. So in 6 months ago, we've seen this in Instagram. We can ask Mathematica to go to any GPS coordinate, and you palm me about 100 over pictures of people who took there randomly, and we can use Mathematica to do analysis about what's happening there. Yeah. So now, if I want to do more robust computation like this one, I say, okay, I'm not interested in first 3 pictures. I'm interested in the 4 pictures. Can you show me what the 4 pictures is? It come out. Then I say, I want to find out how many faces inside those pictures. It will give me some numeric output about faces that it can automatically detect. Of course, this algorithm need to be further trained. It might not be the best output yet. And we can further fine-tune the algorithm so that it can actually detect faces more in an accurate manner. So those are numeric value, but I want to see graphically actually what's inside there. Those in numeric value. We say, please show it up to me. Our faces detect. These are some faces you can detect. Of course, the picture, in order to detect someone's faces, usually it requires a person to look forward like this. So side face is slightly difficult. So some side face might not be able to detect, but at least it detects about 2 faces and also an elbow. Not too sure why. I've not been trained properly yet, the picture. But it doesn't matter, you get an idea. So now we say, okay, those pictures is taken, I want to trim it out. So I trim out 3 faces together with elbow and 1 small face there. And I say, okay, I want to list it out on the table, all the pictures. So all the 4 pictures, as long as faces facing forward, it can detect right away. Of course, this is not just wonderful saying, oh, Peter, you had Instagram coming up into Mathematica. Yet, if I do not have the license and want to share this application with someone, I still get limited because everything now is Internet of Things. So what are you talking about? So the very powerful part is, if I done all my coding, I say, okay, now, this coding and not just content running inside Mathematica, I want to make other people who make use of my application in the mobile devices in any platform. So now, if I run this thing, it will generate the link for me. And using this link, I can paste to any operating system I like, and it will come out a result right away. It's still generating the link for me. Okay, while it's generating, you get a concept. I'll come back to that. It might take some time, usually about a few seconds, right, depending on bandwidth. The conclusion is, like, I have a couple of examples, but because time constraint, I'll not show it here. Like the example here show that my battery's level. Every time I plug on my chargers, you send 1 data to my data drop. So I'm able to backtrack what's happening, my data charging status in the past few months. This is the status of my data charge. So indeed, with the same principle, same approach, you can pretty much track everything you could imagine in your mobile devices. So what will be a future trend? Future trend, I think, if I illustrate with this one last example, I think I like this to be not just my personal inspiration, but I like to hopefully become an inspiration to many of us that when talking about components Internet of Things, and according to research at MIMOS, you say our future resources are research, 5% should be about in a communication network. Yeah, this is done by big companies, by TM, by DG, by Masses, and component of things like data drops, storage data. People have done it by Wolfram. Yeah, people like Wolfram or MIMOS, and things hardware protocols. Those are 10% resources people put in, but major resources and time that areas look at is the data analytics. So the thing is today, I hopefully inspire everyone is knowing that technology in terms of hardware, in terms of cloud, in terms of computing speeds, now almost available to all laymen like you and I. The thing is that we as researchers, either in private sectors, academic sector, think we should focus on how to inspire our further lecturers, researchers, and my students. 80% of resources should be contributed to how we develop ideas, applications, data analysis, as a feedback, as solutions to consumer user in the market. So now, before I close my last slide, I'll just go back to this link. Yes, done. So with this link generated, okay, I click on that. I can make this link to any mobile devices and bake into my programming. So whenever actually I take pictures, auto pump to my Instagram auto pump to data drop, it auto pump to my Mathematica. So all the pictures, the face recognized just now, it can show up inside a simple link, which you can embed in anything, anywhere you like.